Hello. Okay, welcome to the class, our cybersecurity. Um, since we are trying to do it hosting online before I get my car back and able to commute back to the campus, I will see how many students are taking the class online like real time in this moment. If we don't have many, I will still try to host the meeting like our class. Maybe I will group them together, maybe like as a 3 hours class, maybe just at a week, and then you can watch it later. So I will see observe in this week. Because I don't know like when can I get my car back, maybe 1 week or 2 weeks or maybe longer. So just wait more for my latest update. Because I try to avoid like keep sending a message saying okay we keep doing online or not. So just like wait for my email or announcement on D2L. So if we can switch back to face-to-face, then I will let you know. Otherwise, we'll keep doing online. And the second thing is that maybe I will see how many students attending the class like in real time. And you feel free, then you maybe ask me question or we have more like interaction. Otherwise, I maybe just like recording it or just like recording the class as like 3 hours and keep going. Then you may not require to attend the first day class. So I will see based on the feedback. Okay.
Sounds
And
good.
yeah, that's which way do you prefer? Like, do you want me to? Because we only have, I think, okay, I think we have three more students. Okay, total we have three right here. So which way do you prefer? Like, do you want me to keep going like recording the videos for like almost not really complete 3 hours because when we have interaction, then it will be maybe last and longer, and maybe I'll give you a break or I can like record it around like 1 hour, then you can take a break and or you may leave, I can like finish the rest. So I will see. So please let me know after I finish like part of it. Because for today's lecture, it will kind of like cover for 2 weeks. But I will see if we can cover most of them. And mainly for the class today will be some like vocabularies, just like definitions you need to know. Because I don't like students to really memorize all the definition, but you need to know also like have a kind of like understanding, okay, what are they used for? Or then in the future, maybe you are taking other courses, maybe you're taking networking or other advanced course, then you'll know, okay, what we are talking about. Okay, of course, I will including for the later, we have some like encryption methods, and I will try to add some labs to let you to understand, okay, better, not only the definition or like how actually it works. Okay, so let's start off class today. Firstly, we talk about the network interface. So what's the network interface? It's just like for the data they were going to transfer in or out of the computer system. Okay, and they can be in as a hardware. So actually, hardware would be the interface can be we can plug it to the Ethernet cable. Also, we can be the software if you see the ETH01, so they are pop. Or maybe if we are using the virtual computing. Okay, so if you are using, let's say, the VM, some of you maybe try to using the AWS EC2, or if you try to install the VM, let's say the VM Fusion workstation belongs to VMware or like the UMT others or like VirtualBox, you'll see for the one of connection. So that one will be the virtual one, is more or less software. And because when we look at the networking interface, sometimes it comes together with the we call the MAC address. Later, of course, we have the keyword. If you see right here, if you see the network, and then it comes with the MAC address, like where you connected to. So all this. And the virtual machine are simulated in the software, that's what we say, also using hardware to simulate. And we including the LAN and WAN. So what's the difference between LAN and WAN? LAN is the local area network. So when the network or the portion of the network, so they are not like properly accessible to the greater network. So with example, maybe the home or office, maybe campus, so they can be the LAN. Okay, then maybe you have a question, and then how about if I have some like subnet or something? Also, there are some like belongs to LAN. So really, how depends how we can now declare. Sometimes maybe ambiguous, like, and about the WAN will be just like extensive than the LAN. So we combine all the like internet to a larger, even like beyond your computer control. So when you access, maybe make it more easy if you have a router, so internally you can access it will be your local area network, will be your LAN. So when you go south, so you can see there's a pub if you look at the router. So one of the you the Ethernet interface will be called a WAN. Okay, so this means the network coming from outside to inside. Okay, so here's the two keywords, LAN and WAN. And for the communication, we're sending through the package. So for the package is the basic unit of the information. So we'll transfer over a network. So typically they maybe have several additional pieces of information to ensure the proper delivery. When we go through like from the application layer, go down maybe the to even the lower data and the link layer. So we have different way to transfer. So we could have more information and including things like those like TCP/IP. And when we try to communicate over a network, so those package, they are enveloped to carry your data. So in pieces from one endpoint to the other. Okay. Just imagine it. So if you have an envelope, carry a message to sending out. So supposedly it includes the name, street, city, state, right? So also you will try to put your return address. Some of them optional, but those like maybe the stamps, maybe the post office. So they have like postmark over the stamp, so it's sending out. So maybe including, so it kind of like the idea of like the handshake, like guaranteed destination. When we talk about the envelope, so you say the package and envelope, what's the difference? Like for the envelope, maybe you have all the message, but for package, it kind of is actually is a chunk of your original message. That means that let's say if you have a maybe I make it really simple. Maybe let's say I have a sentence and I have 10 words over there, then every word will be one package. So I would break down all the 10 words in a sentence to 10 packages. So I was sending the package one by one. So the receiver, that means the destination receive 10 package, then we will grouping them together, make the orders so you can read the original message. That's how it looks like. And in the network devices, you will see some terms. We say the host. Host can be like any device. So if you see the words that we mentioned, so if I say, okay, what are the hosts, then will be the device on the network. And then the hub. So they will hub, it will take all the package, then they will place on all the ports. Okay. And switch. So they will take in the package, they will read the MAC address of the destination and forward to the MAC address. So here's the differences. I'm not so sure like how many of you really like touch on with the hardware or like at home. If you have a router at home, so that one is more likely is the switch. So you see the brand comes in and then you have like maybe 4 ports. So those 4 ports will be switched. Like you can connect to maybe your printer, desktop, or other devices. And the differences is like will be from the sender to the receiver. So they will try to read the MAC address. Actually for the switch will be like one level higher than the hub. Hub is just like typically repeat all the package and then forward to all the ports. That means even I'm not the receiver, I will still receive the package. Once I receive the package, then if I know, okay, it's not sending to me, just like in case just thinking if there's a post office and then receive an envelope, a mail, okay, receive it, it will just like make a copy. make a photocopy, and then send to all the connected location. And then if you're the receiver, we say, okay, this one is not sending to me, then you drop the package. That's how it works. We know sometimes we need to know that like why it working physically, and then what's the potential risk. So if in the LAN network and all the hosts inside, if you're using hub, that means if I'm an attacker, and then if I plug in or like I connected to this network through the hub, then maybe I'm able to receive all the package. So if you are trying to sending access to a bank account, or you try to withdraw the money, sending money, if I'm an attacker inside this hub, then I know all the package. So that's why it's more dangerous. Okay. But it's like barely, because you need to like physically connect to the hub. And then for the router, most of the time we say the router. So it will take in the package, will read the IP address of the destination. And that's what they're using to talk will be called the routing information protocol, RIP. So that's the router. Okay. Sometimes we say the home router. Actually, a home router includes in physically it combines three parts of it. So one is the router, one is the switch, and then another one is the Wi-Fi and TV. So actually for the home router, even though we call it router, actually it contains three components. In the enterprise level, or sometimes it's more like specific, router only has a router function. So it doesn't contain the switch function. And then you need to add an extra switch, like to forwarding, like connecting to each other. And then you will see a lot for the definition, we will mention about protocol. And protocol is all the rules and standards define a language, like which maybe the devices can use to communicate. And we use large number of protocol in the networking. So for different purpose, we call the TCP, UDP, and maybe the like FTP. So all these will be the ending with the P there, or the protocol. Sometimes like for the hardware to hardware, software to software, and just like maybe if for the traffic light, like just imagining for the traffic light, so the protocol is like red light stop, and then green light go, and it apply to a maybe all the vehicle, maybe the all the passengers, whatever. So on this, and sometimes you hear the port. So port will be the address a single machine. So they can be like tied to a specific piece of software. Enable the computer to be like able to communicate using more than one application. So it's not a really physical interface or location. Later in the lab, I will ask you, okay, maybe allow. So one of the application is the I will give you, after you create the VMs or the EC2, you need to allow, I will let you install NGX. NGX is one of the servers, like helping us to handle for the web server. Okay. And for the web server, we need to allow, if for the website, we most of the time would be HTTP. So it's the one of protocol, and then we're using the port 80 for communication. And if you see sometime when you go to some like certain website, you see there's a HTTPS. So what's S? And then we are using the port like 443. If you did try to remote control a computer, then we have like 3389 would be like for the remote desktop. So for all this, we have different port to specific service. And why port is so important right here? Because lots of we call the maybe the risk, we call the vulnerability, or it's a battle. So kind of a battle, because for some service, they maybe open certain ports for testing application. They request open certain port. They forgot to close it, or they let it maybe for some application when they integrate together, they never realize, okay, maybe some function, they open certain port, they forgot to close it. So they cause the risk. That means let the attacker to like access to your maybe server, your desktop, your any devices. So that's why we need to pay attention. And in the lab, and then I will see, okay, so all those port will come with the number, okay. And also another one is called the network address translation, NAT. Maybe sometimes if you look at your router setting, then you will have a better ideas and know how it works. And for the NAT is try to translate the request. So they are coming incoming into a routing server and then to a device or a server in those like on the LAN. So it's for the NAT doing. So the device outside the LAN only have a public like facing address, right? So of the NAT device. So that one will be the router. So when the router send a package along the intended like destination, so once they receive the package, what you can imagine there's a mailing group in the large organization, or if you're living in a house, then maybe hard to imagine it. In case, or you just thinking maybe if you're living in a house or if you're living for the apartment, you always have mailbox, right? And you some people mail to you maybe have a street number, okay, and you will maybe the postman, the post office, they like deliver to this address, and then you have a mailing box, okay, so or like it's a mail room. So when the letter comes in, then they go to this address. And based on the actual destination, that mail room will be sent those letters. Okay, so based on the number, then I know, okay, so this one goes to the room 1, room 2, room B, or room A, room C, room D, like this. Or like any like office location in the building. So this is how it works. It's we call the network address translation. And we call the NAT device. That's like what the router is doing. So maybe from the public it comes in. So you need to imagine maybe in the networking class, if you're taking networking class, maybe you will see more detailed explanation how it works. But for cybersecurity, you need to know, okay, there's of course like we talk about cyber, that means like something on the internet, then we need to know how it works. And the OS models. So right here will be the layers. If you hear what I say, something what's the application layers. So all this will be like separate logical operations. When we have the communication, start with the application layer. We always start with the highest number, 7. So it's called the human computer interaction layer. So where the application get access the network service. Most easy or like straightforward is the Chrome. Like if you're using the Windows, maybe the Edge, or if you're using Google Chrome or Apple, the Safari. So they can be the application. Or other application, if they will connect to the internet, then also they belongs to the application layer. And when we go down one layer lower is 6, it will be the presentation layer. So in the presentation layer, it ensures the data they are like in a usable format and where the data encryption occur. If you try to look at the web page, then if we need to connect it, then how can we actually work? Because we're talking the package, right? So all those like package or the data, maybe when you try to log in, then you send like username and password to the destination to the server. Then how those like data being encrypted and also like making with the usable format. So this is what the presentation layer will handle. And section layer, it try to maintain the connections. It's responsible for controlling the ports. We talk about the ports. So right here, maybe the sessions. So on session, maybe like save as a cookies, like make sure like you are stay in active connection. And when we go down, I say transport layer, level 4, so will be the TCP, or sometimes I say the UTP. Sometimes you see we always mention TCP IP. So TCP and network layer like IP, so they are coming together. So for the transport layer, will be transmit the data using transmission protocol. So including protocol, maybe the TCP, UDP, FTP, all this will be the transmission protocol. And network layer will be decide which physical path of data we take. So will be the network layer. And then data link. So we define format of data on the network. And then physical layer will be really transmit the bit over the physical media. So this one is like really the cables, maybe Ethernet cable or the optical fiber. So what is. And when we goes down, so just like it's more like conceptual framework. So from the applications and then presentation, session, transport, network, data link, and physical. Okay. So we don't like no network is a pure OSI. So just like remember, so they're not only pure. And the abstraction of all these steps, so in a reliable network, so really from top to bottom and out again. So when we are sending out from the application, so maybe the links the user and the information. So mainly it's a visualization of data. So it's presenting. So that's what you can see. And in behind, so we'll convert what you can see, like those are data, maybe like compressed, encrypted, encoded in format, maybe just like in a plain text format, will be in the presentation layer. When we go down, we need to send out. So we'll break down the data into trunks. So we say that they will be like the package. So they will transmit we say across several sections. Maybe just thinking of a phone book like through the tube, just like this. So it's in the session layer. And when we go down to transport, so we try to support some reliable communication over unreliable media. So why is it? Why we say the unreliable media? Even though say, oh, are we even we like connect through that like really physically or something like Wi-Fi, like cellular. So they're all the media. So here the media that means like the platform we really physically transferring the data. So with that physically, maybe using the bit, like that means the voltage like low high, right? Or the Wi-Fi using the wave. So all different way. And then including for the transport layer, we need to know the like synchronization, acknowledgement for sending and receiving the data. For the transport, we need to so that's why we sometimes including the protocol. So the protocol like comes with the transport layer. So we need to make sure like in which way for communication. Okay. And then after we confirm the transport, that means that by all those protocol, and then next we move down to network. We like actually for the network layer, so including the address, routing, there's you see that like NAT router devices that were working. So maybe be the pathfinding, collision detection, avoidance. So here's the mechanic. For the details, you may learn in networking course, so how the mechanism, how to prevent a collision. But for cybersecurity, you just need to know, okay, how it actually works. And then maybe which path the data takes from here to there. So that's the networking layer with in charge. And then the data link layer, just like makes sense of a pulse, like 1 and 0. So they just recombine the pulse into a collection of data. Because when we really like physically transfer, then you will receive a bunch of like 1 and 0. So then how can we combine them together, become a meaningful content? Okay. And really just like down to the lowest physical layer, just a signal propagating from here to there, like from our sender to destination. You need to know maybe with the like light optical fiber voltage, some radio wave. So we say different medias. So that's what we know. And here's the flow. Always start with the application going from the layer 7 and go down to 1. And then once they received it, then we go up from level 1 up to level 7 and presenting in the application layer. So here's the flow. And when we talk about like address, that means like address we need to recognize. So who they are. Okay. So all the network devices, they have their own unique fingerprint. What is that? That would be a MAC address. All the manufacturer, normally when you check your device hardware, or like if you show, I can show mine right here, I have a MAC address. So based on the MAC address, you know, okay, sometimes if you check the MAC address, you know what are the manufacturer from, because the first few digit will be for the manufacturer and then come with their actual device. Okay, so they will be like 128-bit number. So they will be the hexadecimal like pair, and then you see the first three will be identify the chip manufacturer. That's right, generally. Maybe when we have more manufacturer. So you see, all the manufacturer producing like those hardware, they need to be registered and then come with it, like come together. And you can calculate if there's a hexadecimal pair, and then with the like first three is for the identify the manufacturer, then how many manufacturers can be registered or like extend more. And then last three will be unique to the device. So we can check. So they are, we call it the MAC address that permanently burned in device. So they are unchangeable. Like what I say is almost, because sometimes we can like pretend and change it. Okay, so or like pretend you're another one to this one is like pretty outdated. I'm not so sure like how many of you did try to work like config or like work on your router before. Maybe if you need to access some application or sometimes you need to change your IP address, renew IP address. The fastest way is change your MAC address. But when you change your MAC address, sometimes you cause some connection issue. But just like I'm not going into details. So it's like that's what I did before. Like, okay, I can like pretend modify the MAC address. When you get the MAC address, they will renew the router thing, like think you are the new device connected. They will assign a new IP address to you. So that's how it works. But of course, you need to reset it and change it back to original one. Okay, then that's how it works. And apart from the MAC address, then you see the IP address. You see a lot. You will see what's the IPv4 and IPv6. For the IPv4, it's the like 32-bit number. So it will after test. So right here, so it's like it separate from the 000 to the 255. Okay. Of course, you can like try to do using that static or dynamic IP address. Okay. With static, that means that you will assign the device with the static. Sometimes if you get some device, maybe some printer or some maybe small if you did try to maybe some like Wi-Fi extension, okay, so maybe they will let you to access connected to get to it, or nowadays maybe they will let you to connect to their like their Wi-Fi first, and then you can update the setting connection. So that one maybe comes with the dynamic IP address. And we also have some like called the private address. So if you see the private address, maybe like comes like 10, 192.168, 172.16. So all these will be like designed for the private address. If you look at the campus IP address or maybe your home router address, maybe like always coming like this. Of course, you can change and modify your IP address. So you can change it. And when we move on, we talk about IP address because like it's the 32-bit number. Because when we have more and more devices released, and nowadays even more IoT, that means that more small stuff, and then they require the IP address. So it's getting popularity, and then because the scarcities of the IPv4. So in 2015, so US already one of the IPv4 address, so we just allow it comes out IPv6. If you look at the IPv6, it's also like a format like hex, and with the longer. Let me the okay, mine didn't show up. Depends on sometimes you will see some IP address with the longer address, so it can support more. So it's the 10 to the power 36, so it's pretty a lot. In this moment maybe enough, but when we like keep on like increasing more IoT stuff, then we need more IP address. So maybe IPv6 maybe not able, then it comes up higher. Okay. When you want to check, maybe you are following, then you can using a command like ipconfig, and or then you can check the information, or for the Mac or using Linux system, you can also using the ifconfig. And if you look at your cell phone, maybe if you use your iPhone, go to the about, or Android, go to wireless setting. So all this. Okay, so I can show you. So we can check the config, and then right here. So right here it comes out. If I type, then you will see all the connections. You see the interface. So yeah, so interface, possible interface, and then we have the bridge. So you can see like in more than what you know. Like sometimes we have the ETH0 bit, the port comes out. Sometimes we have the LAN, Wi-Fi, and other interface. So you see more details. And then they always come with their MAC address. And also sometimes you'll see the maybe the IP address, internal local host IP address right here. So if you're interested, so you can try to check your device using the commands right here. And then how can we know like actually like recognize? Because if we look at IP address, like first it's really hard to memorize. Then you know we have some domain name. So we using the domain name system. So we'll the server port a lookup service. So we'll refer to as a YP. So they have an authoritative and mirrors. So they will ask about the ICANN. So this one have a register. So you cannot create by yourself. As you know, if you need to purchase the domain name, so they should be the unique. And if you're working on the server, so if you, that's why I recommend you using the EC2, because using AWS, then you can look at it. When you create the EC2 instance, you will see the DNS. So that one will come like belongs to Amazon, AWS, and it will have some names. It's more specific. So they will create the dynamic domain name with some like we call the A record or AAA records, and all those like will refer to without to the IP address. And then when if you look at your EC2 instance, then you see you have a IP address, also the DNS. Also, you can SSH connect to the EC2 instance, the node using the DNS or IP address. Either way is okay. And for the DNS, we have some like root name server maybe located, and then for any case instance right here, and then maybe other locations. That's how it actually works. And we talk about like transport layer, and then we have some like protocol, and you may hear what I mentioned is about the TCP, and the TCP is the full name called the transmission control protocol. Transmission protocol, and then the internet protocol TCP/IP, which is say mentioned so many times, and then you see so many times. So it's about the addressing, also including the three-way handshake. So it will include the synchronize, and then synchronize with the acknowledgement, and then later we give the acknowledgement. Then we can start our communication. This is what the TCP/IP working. And for the website, we have the HTTP and HTTPS. So that's what I say, the HTTPS, and then it comes with the SSL. So, And then we have the FTP. So if you connect to server, then maybe the file transmission protocol. So how can we upload, sending the files? And for the email, so you see something like the POP3, POP3, IMAP, SMTP. So all these will be like using for the email transmission. One is like you're receiving. I don't know how many you try to set up or like try to configure it. If you're hosting a website or like say connecting the maybe you are using the Outlook or maybe, but when you configure the setting, you will see maybe they have certain protocol using for the, you can choose. Maybe you are using SMTP, so you can like sending, receiving email, some are only receiving, some are receiving. And Telnet and SSH is one of the protocol. So that's why when we using this protocol, you see the port. Normally we're using the port 22 for the SSH, like remote access. You will see when we try to connect, and then from the example SSH, and then with our downloaded certificate, the PM key, and then with the destination. So here's the protocol we are using. So that's what I put. And we talk about the ports, right? So the ports, like 22 will be our for the surface, our FTP. So transfer the files, and then 22 or 23 for Telnet SSH. So SSH will be encrypted, and most of them we're using will be using port 22. You can define with a specific port, or you can change another port number for this service. And port 80 and 88, sometimes for the HTTP. Here's will be say HTTPS, or like we're using 443 for HTTPS, and S will be also included with the SSL. That means with the certificate. And then port 3 IMAP will be for the mail retrieving, so it will be like 110, 143. And of course, we do have other port. SMTP 25 for email transmission, and 53 for DNS server. If you look at the Google, let's say, and let me search Google SMTP. Right here, you will see more port, maybe with more like encryption, other like TSSL or TLS protocol. If you're confusing, then you just need to know we have some like protocols. And you see port like 25, 465, and 587. So you see we have more port instead like only those. Because all these will be the basic, and you will see long time before. Because when we want to increase the security, so we try to add lots of certificates, maybe the asymmetric encryption. And within the encryption, when we adding encryption, maybe those port will be changed. Sometimes we try to maintain the lower security port, and some with the highest, and we're recommending like using the highest. Then you may be asking a question, yeah, if we shifting from the lower security to high security protocol for the port, then why are we keeping those ports? So I left a question to think. Yeah, even for the Google SMTP, it still exists 25, but you will see we have the SL or like TLS. Then why we still need to keep the like the one lower security? Then you may think about that. Okay. And here's some command line you can check, maybe using the paint to check the return. If let's say, okay, I have terminal right here. So if I want to ping the let's say google.com, okay. So it was sending the request, and then it shows like all the IP address. The reason why you see like the protocol social is not support. Okay, let me terminate. Okay. There's some mechanism, and or for security or some like firewall, they will reject the ping if some companies server they don't want to like bear too much workload. If you later we talk about the DOS or DDoS. So it's how the mechanism it works. So they don't want to like overload their devices, then they try, sometimes they reject the thing. Okay. And also looking for the IP address, NS lookup, or like the trace route and trace share, depends on which platform you're using. If you're using Windows, then you can look at it. For the practice later, maybe I'll give you exercise to like this to try to execute all this using a command and check your IP address. And then later for the package you here, so they will contain lots of information in the plain text in the package. So they will maybe have specific order, so included in the header, and also the network devices. They will read the header to the route information. So those like plain text including the source and destination, they have sequence number. So this why maybe I say as a complete sentence, then we break down into different chunks, right? So different chunks when we're sending out, sometimes the sequence may be in order because maybe some package will go through different route. So they are not arrive sequentially. Maybe the first package, second, and then the third package will be arrive later. Then we need to reorder it. And then we have the acknowledgement number, some data offset, reserve, code, and then including some like maybe some checksum, urgings, padding, like and the exact data. So here's all the headers. You just need to know the what's the okay or some terms we're going to use. Okay. Then what's the problem? Oh yeah, we know that. So for the internet, so maybe actually all the networks, they are unreliable. So we're unreliable for all the media. So we have two like general problem. So they can separate by the value. So they can control by the guys. So if they're only successful if they can attack each together, then how can they coordinate and attack and be sure the proper time? So it's always unsolvable. So it's just the issue right here. And we still figure out like how to make it more reliable. So still trying to do it. So that's why we need to provide some algorithm protocol to make it. So maybe who goes there first and then who transmit when and then expose. But we do have some like potential back off. Maybe try to like sending receive from the host synchronize. Maybe we'll try to wait like first time. Maybe we just like wait for 1 unit of time. Usually we're using 1 unit time because it's not really actually 1 second, maybe 1 nanosecond. And then for next time, we do a collection that we will try to wait for 2 units again, or next one we wait. Then we can try to wait it. And is it possible waiting for forever? It's a loop. Then we will get the timeout. Okay. Then how can we set a timeout? So everything we try to make the algorithm make sense of it. So maybe the additive increase or like multiplicative like decrease. So like this. So as soon as they maybe one package is sent or receive, maybe 2 more are sent, keep going on. So as soon maybe as one package is lost, then we can like drop it by half like this. Maybe one of the method we can like the algorithm we're going to use. And you can looking for some extra information too if you're interested, some like reading this extra if you're interested. Okay. And here's like more information about TCP, the transmission control protocol. For the transmission protocol, we'll implement like in the transport layer of the TCP IP model. So we are using it to establish the reliable connection. So we try to break the data into packages. So like the trunk like pieces. So the TCP, they are built up a connection prior to the data transfer using a system we call a three-way handshaking, three-way handshake. So it allows like 2 ends, maybe a device. So for communication, we send acknowledgement. So they request and then agree upon the methods, ensure data reliability. So it's kind of a concept like before we start to talk. So right here, then we start to say maybe like, hello. And then when you reply to me, okay, I can receive it. So I'm going to send the package to you. So kind of like, hello. And then you reply to me. And then, okay, are you ready to talk? I'm going to talk. Then his account will be the content. So it's the most like popular way we use for application or the web or email, FTP, SH. So we're all using the TCP. So it's more reliable. And then we have another one called user datagram protocol. So this one is the conventions protocol to TCP. So also implement in the transport layer. So UDP it just like offer unreliable data transfer. So it do not need to verify the data has been received. So really, I don't really care about it. So we are not waiting for communication. So it will be faster sending out. So here's the advantage. We just sending off the data to a recipient, and then I just don't care. So is it being accepted or not? So really simple. So you see all the right now streaming communication like the video, podcast, video games, VoIP, the voice over IP, this one like queuing the network devices. So all this we using the UDP. We see the disadvantage, like of course we try to secure connection using TCP. So when we introduce the UDP, of course there's some reason, because there's a reason we don't need to create unreliable data transmission. So if we need to really have go fast, stable, like video, if we lost a package, sometimes I'm not so sure if you maybe watch, no, right now it may be pretty stable if you, let's say if you're watching YouTube, Netflix, maybe sometimes you experiencing maybe a little bit loss, or like if you see a square or something, maybe the video image it didn't really clear, maybe it lost certain package. Or maybe you watch the live, maybe the football games, basketball games online. Then maybe you see, okay, sometimes you lost 1 second, but actually it doesn't matter. So it won't really affect your using. So that's why we are using the UDP. And then you hear a lot, like for the website, it would be the HTTP. We say a lot, it's the hypertext transfer protocol. So this one is the protocol defined in the application layer. So just remember, this is a protocol like defined in the application layer. So it forms like basic communication on the web. Also, it also defines the number of the functions turned to remote system what you are requesting. So maybe the get, post, delete, or the interact with the request data in a different way. And then I will try to give some sample code like running host the API file, then we see the get, post, delete, what they're doing. Build for cybersecurity, I try to give you some lab to see, experience, and know what they're how. Give you some example, look at the source code. Instead of just like remember all this keyword, but have no idea what they are doing. But I will try to cover all this, like give you some sample. So that's why I'm trying to let you to set up or install the necessary application. And then the next one will be the file transfer protocol. And after this, then we will try to take a break. And then if you want to leave, you feel free to leave. And maybe I will just like keep on reconnect. So the one is the file transfer protocol. So this one also in the application layer, also it's just like telling how to transfer a compute files from one host to another. So if we need to send a file, then we are using FTP. If you did try to access to the like EC2, if you want to send a file, then we can using the the FTP. Like you can maybe the FileZilla. So that one is using the FTP protocol. So it will like inherently like insecure. So right now it's not recommended except some like public or download only resources. And right now we have one called SFTP. So come with the also the SSL, so with the certificate, so it's more stable. And we talk about the SSH protocol. It's a secure shell, so it will encrypt the protocol implement in the application layer. So used for like communication. So with a remote server security. Of course, like we have some many like additional technology built around this protocol. So because like it's an end-to-end encryption and ambiguity. Okay. So this one is the first one for the lab. When you set up, we are using is the SH protocol. So when you connect to the server, and that's what you are going to use. Let me clean it. Okay, so SH. So you see right here, I have an account IP address. If you're using the certificate, so you come with certificate and then with the Ubuntu account name and then with the AWS DNS. So right here, so here is the one you first time using is the SH protocol for communicating with the server. And I did show you what's the IP config or IF config for the TCP IP configuration or sometimes for the Linux. Because for the Mac Windows also is based on the Linux based or Unix, somehow Unix based. So we're checking for IP would be similar with the IP config too, but more like functionalities. I recommend if you are interested, always try and then look at those details. And those two can tell what do you have an IP address, and then you can reset DHCP. So DHCP, if you remember, we talked about the IP address, IPv4, and then we have the static, dynamic, and DHCP will be the server that help us to assign maybe some static IP address or dynamic allocate IP address to you based on your MAC address. So all this, so it will be a fair amount of the network troubleshooting involved like using this tool. Okay, and here's the interface. It looks like if you're on the Windows IP config, so it will showing okay all the DNS, maybe the physical address. That means the address. Sometimes we have different names, and then we have the DHCP server and the V6 right here. And sometimes you will see we have the subnet mask. Some mask will they showing you belongs to this LAN or out of this WAN. For the details how you exactly calculate and read, then maybe let the networking class to cover, but just let you know how it read. Okay. And also for the Linux system, we using ifconfig and then show that all the interface and belongs this interface. We have what the IP address, subnet mask, and where they broadcast, they maybe will be the they are not to handle their gateway. So sometimes you see different terms, different names, but it representing like let's say the gateway will be your router, so the destination you're going out. The NAT helps you to redirect. So that's all the term. And then maybe the IP link. So it will be the status of the network link layer device. And then the IP address showing, okay, your address like assigned to this device, maybe my address IPv4, IPv6. So here will be showing the IP address show command line. So I would let you to try all this. And I think it keep going, takes almost the time. So we still have a path. So if you want, you can I will give you a break, and then you may not be quite, because as a first day, I don't think, because you only have 4 of you are attending it. So probably I guess maybe on Thursday, I don't have so many students taking. So I think I will keep recording. So you may not be required to attend the Thursday class, unless you have the some like issue to setting up on a AWS EC2 or the VM, then you can send me an email. I will give the Thursday class time for you to help you to resolve the problem. Okay, and I will make a pause right here and keep going after 10 minutes. So you may take a break if you want to stay. If you know, you're free to leave and watch it continues. So here will be more like details all about the commands we are using. Okay, so I will pause right here.